Okay, welcome back. This is Foundations of Technology, the second unit. We're going to go over develop and design solutions. So the first stage was identify the problem. Second is to come up with ideas, and we're going to talk this unit about coming up with different ideas. So first we want to know what designs can we come up with. Well, there's two types. One's a system design and one is a product design. As you can see, the system contains of a bunch of parts working together. We should have learned that past few years in 7th and 8th grade. So a system is a bunch of parts working together. We can either design a system. Here's a couple of examples. A computer system, which contains the monitor, the CPU, the tower, the mouse, the keyboard, the speakers. You can keep going on, all the little pieces that make it up. Then there is a product design, which is just one of the pieces that makes up that computer system. For example, if you look at the monitor itself. If you go to Walmart, you can go buy a monitor by itself, a mouse by itself, a keyboard by itself. So there's different types of designs. Again, it's the whole system itself, which would be, look at Apple, Dell, Sony. They make the whole computer system by itself, but they also are in the market of producing one piece by themselves. So we can have those two types. Now, when we start thinking of what the problem is, we have a problem, we want to solve it. We need to go through and gather information, know what we're working with. And here's a list of stuff we're going to do. Always go find out what's been done before. There's no point in going through and recreating the wheel if it's already been done. So in this project you're working on, which is the robotic problem, go out and see, research, do some online research, see if somebody's already created something in the same format of what you're doing to make your life easier. So historical information, do not recreate the wheel. If we're going to go out and build a 15-foot bridge to span 15 foot, we're not going to start over from scratch. We're going to go find out what has already been done before and probably recreate that 15-foot bridge. Okay, the scientific information, you've got to know the laws, the formulas involved. Again, if you look in the tech lab, we have scientific information telling us that slab of concrete can stay above us without falling in on our heads whenever we're sitting there in the lecture room. The engineering principles behind it tells us that it's okay to have the metal, the steel running side to side and then a piece of concrete sit on top. But it's going to be okay. So we need to know if it's going to hold everything. So when you're creating your robot, is it going to hold all the weight up front? Is it going to move like it's supposed to? Is the gears correct? Are they going to function properly? Then we get down to technological information. We've got to know what we're working with. Again, if we're creating that bridge that's spanning 15 feet, are we wanting to work with metal, woods, plastics, aluminum foil? I know I'm throwing aluminum foil out there just so you can know that we're going through Foundations of Tech. We went through 7th and 8th grade technology, learning how to process materials. And so you can have a better understanding on how materials work, how they function, and now we're starting to put them to use. Make sure we understand the process that goes along with making something new. Hopefully this isn't new terminology for you, but we need to know how it reacts with a human, the ergonomics. Is it functional for a person? Is it comfortable for your hand? For example, when we make a product, if we're making a mouse for the computer, does it fit your hand? If we're creating chairs, does it fit the curve of your back? Does it look pleasing to the human eye? We've got to make sure all those things are in place, otherwise we are not going to want to go out and purchase this if we are the one creating it. Legal information, make sure we're not breaking any rules, obviously. We've got to make sure that everything that we're doing is under federal guidelines. So that's another big part. What we're doing in class, we really don't have to worry about this one due to the fact that we're doing for education, and it's not going to be a huge part. We're not breaking any laws. We're not. There's no regulations that we have to worry about doing these little robots that we're working with. And the last one, ethical information. It's kind of low key in the United States, but if we're global marketing, if we're making something for the world, we've got to make sure that we use the right colors, because certain colors in other countries mean other things. Also, we can't go in and just create technology and put it in any country. Not all countries accept everything. For example, not all countries have the internet. It's against their ethical beliefs. A lot of countries don't have computers. Again, same situation. So we can't just go out and create those new products or new systems for anybody. So we got to make sure we're doing it for the right people, the right reasons, and so on. And in the United States, we really don't have to worry about it too much. Now, I've got this guy up here, Sergeant Oso, or Special Agent Oso, and I want you guys to remember him. If you've never watched the show, he always has 3 special steps. Okay, so we're going to go through all these special steps, and you're going to remember this throughout the entire semester. Everything is in groups of 3. Here it is. First thing we're going to do is we're going to come up with preliminary solutions, basically brainstormed ideas. Then we're going to take the brainstormed ideas or the preliminary solutions, we're going to isolate it and refine it to make one. Okay, once we find one, which is called a refined solution, we're then going to detail it to make it the best possible solution. So again, we're going to come up with brainstorm ideas, refine it, and then detail it at the end. 3 steps. Okay, here's the developed solutions broken down even farther. The first step is called divergent thinking. That's when we think all these crazy, wild thoughts. We're going to think of those first. I want you to come up with 5, 10 different solutions. Then we're going to take those 5 to 10 different ideas and isolate it and refine it into one. That is called converging or convergent thinking. We're converging into a narrow path. So when we're thinking divergent thinking, we're thinking of a lot of different things. Then we're converging and thinking convergently for one solution. Then the last step, again, 3 special steps, is selecting the best one and making it a detailed solution. Okay, I want to ask this question. Why is it important to think divergently, then convergently? Okay, if we're thinking about sketches, we're thinking rough sketches, then refined sketches. So we'll pause for a second. I want you to think about that. Okay, if you've started thinking about it, you can pause the video however you want to think about it. But if you think divergently, I'm thinking of 10 to 15 different ideas to try to come up with a solution. Then I can go through and pick the best pieces of each of those solutions to come up with one. And that's thinking divergently first, then convergent thinking. A lot of kids don't do this. A lot of kids, the first thing that comes to their head, that's what they want to use. And that's actually thinking the opposite. You come across a lot of problems this way. So it's not a good way to think is to go convergent thinking. Then you run into all these problems, and you got to go backtrack, think divergently, then go through the process again. Okay, again, first thing we're going to do is brainstorm. We use the synergism or synergy concept. Everybody has a piece. Everybody talks. It's also called 1 + 1 = 3. The more people you have in the pie, the better it's going to be. The better the answer is going to be. You're supposed to think of all the what ifs. That stirs conversation, even if it's a wild one that you obviously know it's not going to work. But it stirs conversation. You're also not supposed to react to these. when we're brainstorming, we do not say, no, that's a dumb idea. It should be quick, it should be right off the top of your head when we start thinking of brainstormed ideas. Don't think about them too much. Just jot them all down. These are also what we consider rough sketches. So when we're brainstorming, we're jotting down little sketches. It's a good idea to sketch it on paper so other people can see your ideas. So step 1 is brainstorming. Step 2 is we're going to isolate it and refine it. Okay, we're going to take all those brainstormed ideas, which is our rough sketches. We call that the library of our ideas. Then we're going to go through and evaluate each of those, pull the best parts of the brainstormed ideas, and turn it into what we call a refined sketch. That refined sketch is going to be more of a narrow solution of all of our ideas. Again, that was the second step, and the last one that Special Agent says is the third step. This one's where we're going to go through and detail our solution. We're actually going to make a drawing for it. Detail the sketch, make it the size that we want, put all the information on the sketch that we need. Now, we're going to talk about 3 pictorial sketches. They're called pictorial because they look more like a picture. Okay, and these 3 types are oblique, isometric, and perspective. And the ones we use the most in engineering are going to be our isometric sketches. When we sketch, a lot of people use oblique because they're easy to draw, and perspective is mainly in construction, and we'll talk about that here in a second. Here's oblique. They are easy to draw. You just draw the front view and start drawing lines behind it. Very simple. Doesn't take a lot of effort to draw these. The ones we use the most in engineering is the isometric. It's more of a 3D at a 45-degree angle. So you're going to be doing some of these sketches later that you get the isometric, and you're going to do something else with them. But again, if you go buy a cabinet at Walmart or something you have to put together, more than likely, as a consumer, you're going to have to know how to read isometric sketches. And the last is perspective. These are done in construction. If you look at the bottom, or even kind of the top, perspective gives you an idea where you're standing according to the object. And mainly we use these construction so we can see where or what the building will look like. Standing in front of it, above it, to the side of it, etc. So we tend to we don't use these very much except for in the field of construction and architecture. Okay, the last slide I want to talk about is anything in engineering. There's a lot of different positions or jobs or careers you can go. We're going to kind of go through and teach you some of the things that you can actually go and become a drafter or a technical engineer is what they call them now. But basically you learn how to use AutoCAD. I'm going to tell you that when I was in college, I actually worked for a company, and all I did was drew CAD drawings all day. It paid my way through college. And I only had one class in college that taught me how to use the program. So I know that some of you will actually enjoy this. You'll be able to go out in the field after high school and probably get a decent job in Pittsburgh while you go to school, if that's what you're thinking about doing, or you can go into the field of engineering and you'll be one step up just from taking the course here in Frontenac. Thanks for listening. I hope you took good notes. We'll have a quiz when we get back to class.